Now coming to the next question here, the second question, which I think you would have already tried to solve it. It's a C. It's not a difficult one. Again, the point is, the whole concentration in theory of equation is, can we convert an equation to a polynomial form first? If yes, then further can we convert, if we have to solve, see, if we have to solve, if we have to just discuss about the number of real roots or maybe some relation among the roots, then it's a different story. But if you have to solve it, the objective is to convert it to a proper quadratic form. I'm not saying that without converting it we can't solve it, but then I say if we can convert it, we are 100% sure we'll be able to solve it. So that statement is true always. Okay, if we can convert it to a quadratic form. Now look at this equation. Log of 6x square plus 23x plus 21 to the base 2x plus 3 plus log of 4x square plus 12x plus 9 to the base 3x plus 7 is equal to 4. This is what we have as an equation here. Okay, now keeping in mind the same thing, that we should be able to convert it to some polynomial form or preferably the quadratic form. The first thing I tried was to factorize it. Okay, and this is clearly visible, is a perfect square, and that boosts us and that gives us the courage to try to factorize it with the belief that it should be factorizable. I'm repeating why, because see, once you write it as a perfect square, you get the idea in which direction are we heading. So here you got log of 2x plus 3, and here that number, that expression 2x plus 3 is in the base. So that means this should be factorizable, and we expect this number or this expression to be a factor here. That's how I started. Okay, now let's write it. So this is log of 6 into 21, so 7, 3, 3, 2. So 14 into 9, 23. Okay, yeah. So 14 into 9. So it's 6x square plus 9x plus 14x plus 21 to the base 2x plus 3. And using property of log, I can write 2 times log of 2x plus 3 to the base 3x plus 7. Okay. So now what? So now I can take 3x common here, so it's 2x plus 3 plus 7 common here, 2x plus 3. See, that's what we were expecting actually. So to the base 2x plus 3, and then plus 2 times log of 2x plus 3 to the base 3x plus 7. Okay, now moving ahead. So we got it, so we can write it as log of 3x plus 7 into 2x plus 3 to the base 2x plus 3. 2 times log of 2x plus 3 to the base 3x plus 7 is equal to, see I missed that, is equal to 4, yeah. So I should have written, so is equal to 4 here. Now again, using log a into b is log a plus log b. So I will write it as log of 3x plus 7 to the base 2x plus 3 plus log of 2x plus 3 to the base 2x plus 3, and we know how much is it? है ना बच्चों? So what's the value of this expression then? The second one. So that's it, is equal to 4. Now we know log a to the base a, to any valid base a, is always 1. So this gives us 1 here. So now I can write, see here, but before writing it, now we can definitely simplify it. I will say let log of 3x plus 7 to the base 2x plus 3 bt. Then again, using property of log, what is it? So that's nothing but 1 by t. If we reciprocate, okay, then we can interchange these two things. The base and the input of the log can be easily changed here. So now I'll write it as t plus 2 by t and minus 3 equal to 0. So t square minus 3t plus 2 equal to 0. So that means either t is 1 or t is 2. That's it. Either t is 1 or t is 2. Okay, now see, one thing which I missed, I shouldn't have, but then okay, I missed it, so I'm sharing it now. Since you have log terms here, log has constraint over its input also. and its base also. Okay, so that constraint we have to take care. So 2x plus 3 should be greater than 0, can't be equal to 1. 3x plus 7 can't be equal to 1. So if x is greater than minus 3 by 2, okay, and not equal to 1, what does that mean? Not equal to minus 1, no? Right, okay. So this shouldn't be 1. So that we can solve, x can't be minus 1. But see, and this says that x is greater than minus 7 by 3. So of course, if it's greater than minus 3 by 2, it is greater than minus 7 by 3. So that's the domain condition for at least as far as the base is concerned. Okay, and of course with that it shouldn't be minus 1 here, it shouldn't be 1, so x can't be minus 1, so x can't be minus 1. Now along with that, this has also to be positive. Okay, so 2x plus 3, but its factor is again 2x plus 3 into 3x plus 7 has to be greater than 0, and we know it's an open upward quadratic. Open upward quadratic is positive when it's the x, the variable of the quadratic, is either greater than the larger root and smaller than the smaller root. Okay, so the larger root is minus 3 by 2, so x should be greater than minus 3 by 2. So that's the domain condition of the equation. So x should be greater than minus 3 by 2, and it can't be minus 1. It can't be minus 1, bacho. Okay, now see. Why we did it? Because now we are about to get the answer. So now we will say that let t be 1, which is log 3x plus 7. So therefore log of 3x plus 7 to the base 2x plus 3 is equal to 1. So what does that mean? That simply means that 3x plus 7 is equal to 2x plus 3. Isn't that? Log a to the base is 1. So its x is equal to minus 4. That's what we get. Is it possible? Answer is no, because x has to be greater than minus 3 by 2. See, that's why it was really important. Now we will say the second possibility is log of 3x plus 7 to the base 2x plus 3 is equal to 2. So that means 3x plus 7 is equal to 2x plus 3 whole square. So if we solve it, so 4x square plus 12x plus 9x, and 9 minus 7 is plus 2 equal to 0. So it's factorizable. 4x square plus 8x plus x plus 2 equal to 0. So 4x is common. So either x is equal to minus 1 by 4, that's a valid number, or x is equal to minus 2, invalid number. So how many roots did we get? We got only one valid root, and that is x is equal to minus 1 by 4, because the domain condition for the equation was x should be greater than minus 3 by 2 and can't be minus 1. Okay, so that was the entire approach for this question. The whole idea on which the question was based, to transform it to the simplest form and then see whether we get a quadratic or not. If we get a quadratic at the last, you be sure that we have followed the perfectly correct steps. Okay, there's no doubt about it, bacho. Okay, so that was the question on theory of equation for today.